Okay, so now we will be having another example regarding the algebraic substitution. Say we need to evaluate the square root of x all over x plus 1 dx. Okay, so we have here radicals in terms of x, and we cannot apply the basic rules integration, so we're gonna use some substitution. So say we let our variable u is equal to our rational square root of x. Then in our integrand we have x, so we need to find the value of x here. So to find the value of x, we need to square both sides. So u squared is just u squared, and square root of x squared is just x, right? Because as you remember, this square root here can also be written as 1/2. And if we take the squared of this x raised to 1/2, then we're gonna have a 2 over 2 here, so it's raised to 1. That's why we have x there. Then we need to find the equivalent value of the x, so let's try to take the derivative of the u, which is 2u, then du, and then the derivative of x is just d of x. Okay, then our next step is to change all the values of our x to u. So the square root of x is equal to u. So we have u all over the x here is u squared, so we have u squared, and then plus 1, and then our dx is equal to 2u du, right? Okay, then need to simplify this one. So we have 2u du multiplied by u, so we have 2u squared du, then all over u squared plus 1. Okay, so can also rewrite this as 2 integral of u squared du all over u squared plus 1. Okay, so you can see here what formula can now be used in order for us to solve this kind of integrand. So we have u squared du and u squared plus 1. Okay, maybe we can also do some variations like what we've done before by adding 1 and then by having a minus 1. Okay, then we have du all over u squared plus 1, or 2 integral of u squared plus 1 divide u squared plus 1 du minus this part, the integral of 1 du all over u squared plus 1, right? And then from here we can now easily cancel this out. So we have 2 times the integral of du, so we have u, and then minus integral of du u squared plus 1. So this leads to the inverse trigonometric function, which is equal to 1 over 1. So we have 1. Then arctangent of u all over 1, or arctangent of u. Then our plus c. So all in all, we have 2 multiplied by the value of u, which is square root of x minus the arctan of square root of x, and then plus c. So therefore, the integral of square root of x, the integral of the square root of x all over x plus 1 dx is equal to 2 multiplied by square root of x minus arctangent of square root of x, then plus c.